Homework 3 is on angles and angle measure. So the first two sections we're converting back and forth between radians and degrees. So this one is in degrees right now. So you take 225 degrees and you multiply it by pi radians over 180 degrees. So you reduce everything down as much as you possibly can. So the 225 over 180, you can cancel out, let's see, 45. So reduce this down by 45 and you get 4 here. Reduce this down by 45 and you get 5. So this reduces down to 5 pi over 4. So that would be the new radian measure. For 7 through 12, you're going the opposite direction. This is given to you in radians. So you can multiply this by 180 over pi radians. So with each one of these, you're going to have a pi that you'll be able to cancel out. And then you have 12 over 180, so those can reduce down. So this is actually divisible by 12. So 180 divided by 12 is 15. And then your final answer would be 15 times 23. And that would be 345 degrees. Okay, so a lot of reducing. Calculator work too if these are values that you just want to plug in. Next section, we've got reference angles, coterminal angles, as well as sketching the angle. So 115 degrees, you've got 0, 90, 180, so it must be somewhere in here, and it's definitely closer to 90. It's only about 25 degrees past where the 90 is. So something like that. Okay, so this all the way open like that, that is 115 degrees. So for your coterminal angles, you take the angle, you add 360, subtract 360. So 115 plus 360, that gives us 475 degrees. So that's one coterminal angle. You could also take 115 minus 360 degrees, and that would be negative 245 degrees. Okay, so two different coterminal angles, one by adding, one by subtracting 360. And then the reference angle, remember that's always the positive angle between our terminal side and the x-axis. Okay, so the terminal side and the x-axis is this measurement right here. So if this is 180 degrees, then we're looking at 180 degrees minus 115 to get that distance right here. So subtract that, we end up with 65 degrees. So that is our reference angle. All right, next page we have for 19, 20, and 21. You sketch in this point, so you can sketch the terminal side, figure out what the angle is. So -5, +12. So we can, doesn't even have to be super exact. So -5 and then 12 would be more than that. So we've got this point right here, so you can extend terminal side like that. So you've got this point. And so what I would recommend doing is dropping down your little dotted line. So this right here is a -5, this is a +12, and then we've got that missing piece R. Okay, so each one of these you're going to be missing an R. Now the X's, the Y's could be negative depending on what quadrant you're in, but remember R represents a distance, it represents a radius. That value is never going to be negative no matter what quadrant you're in. So we calculate just the values squared equals R squared. So we have 25 plus 144 equals R squared. Add those together, we get 169 equals R squared. So when you take the square root, we end up with 13. Okay, so R is 13. So now using our formulas, we know that X is -5, Y is +12, and we know that R is 13. So you can use that for all the formulas that we have on the right. So sine's formula is Y divided by R, so 12 divided by 13, and cosecant is the reciprocal of that. Cosine is X divided by R, so -5 divided by 13, and secant is the reciprocal of that. And then tangent is Y divided by X, so 12 divided by -5, and then cotangent is the reciprocal of that.